Hi, good morning, everybody. Welcome to Thursday. Today we're doing 8.4. That's the last section in chapter 8 that we'll be doing. It's on parametric equations. Morning, Jay. Not really a lot to write on the board as far as cheat sheet type of stuff. Morning, Leilani. But I do want to just go through one thing before we get started here, and it's actually for the next sections that you're going to be doing, 9.1 and 9.2. So we're 9.1 and 9.2, we get into vectors, and specifically we talk about unit vectors. Morning, everybody. You guys are a lot more chatty than the 8:30 class. I like that. At least I know there's people here. So yeah, unit vectors, and you notate it with I and J. But if you just use the I and J on your keyboard, it's going to mark it wrong. So what you need to actually do is on Webassign on the right, there's the little pull down menu that you guys use for like your square root, your exponents and things like that, your fractions. In that pull down menu, there's also a little tab for vectors. And in the vectors, there'll be an I and a J button. And unfortunately, you always have to go in there and put I and J for those vectors. Otherwise, it doesn't recognize it as the unit vector. So unfortunately, it's one of the drawbacks of the system. But just keep that in mind when you're doing the homework for 9.1 and 9.2. When you have to enter in I and J, use that pull down menu for I and J. Everybody good on that? Okay. So today, parametric equations, as I sort of gave you guys a heads up on Tuesday, when they're just straight x, y's, and t's, so say for instance, whatever x is t and y is t squared, these are t squared. These are easy enough to do because it's like, oh, just solve for t and plug it into the other equation. If I have trig parametric equations, if I have a trig function and their sine, cosine, secant, tangent, et cetera, then it becomes a little more difficult because we can't solve for t and say that, oh, okay, t is cosine inverse of this, and now plug it in. Because when we're doing conversion to rectangular coordinate equation, my final answer can only have x's and y's and numbers. So I need to get rid of the trig functions. And so to do that, we go into our trig bag of tricks and find out, okay, do I have some relationship between these functions that are being presented to me? Then can I make a substitution? So let me see what you guys hear. I think you only had a couple questions, 2 and 4 maybe. Yeah, so 2 and 4. So 2 and 4 and then 6 and 9 are similar. So we'll do 2, let you guys try number 4, and then we'll go from there. So number 2, we have x is equal to 5 cosine of t, and y is equal to 6 sine of t. Okay. I figured out question 2, part B. Okay. I'm going to assume other people have the question just because a bunch of people had it from the earlier class as well. So I'm glad you got it, Jonathan, but we'll go through it anyways, just so you guys kind of see how these work. So first thing we have to do is sketch it. So to do that, we're going to build a table with our t and then figure out what is x and what is y. If we're not given a restriction, so like number 4, we're told that t is between 0 and pi over 2. This one, we're not given any restrictions. So the values I'm going to pick for t are 0, pi over 2, pi, 3 pi over 2, and 2 pi. If possible, when doing these trig parametric equations, use these as your values. The reason being is what? These values, the x and y coordinates, are either 0, 1, or -1. So you'll get nice numbers in your table. Otherwise, if I pick 0, pi over 6, pi over 4, now I get a bunch of radicals, and then my answers get super messy. And honestly, you don't want that many points anyways. You don't want to calculate all 16 points around the unit circle. So just pick these values here. So if I do that, if I plug t in to figure out x, cosine of 0 is 1. 5 times 1 is 5. For pi over 2, cosine of pi over 2 is 0. 5 times 0 is 0. Plug in pi. Cosine of pi is negative 1. 5 times negative 1 is negative 5. 3 pi over 2. Cosine of 3 pi over 2 is 0. 5 times 0 is 0. And back to the start, 2 pi. Cosine of 2 pi is 1. 5 times 1 is 5. Any questions on those before I start into the y values? And again, if you have a question, just hit the exclamation point and hit enter. That way I know to stop while you're actually typing out the question. Otherwise, if you're busy typing out the question, we're going to be halfway through the problem before I ever see it. Okay, so now figure out our values for y. So plug in 0. Sine of 0 is 0. 6 times 0 is 0. Sine of pi over 2 is 1. 6 times 1 is 6. Sine of pi is 0. 6 times 0 is 0. Sine of 3 pi over 2, negative 1. So this is negative 6. And then back to 0 again. So now that I have my table, I can plot these points. So now I'm not even worried about t anymore. It's just my x's and y's. So first I have 5, 0. So that's over here on the x-axis. And then 0, 6. So that's up here on the y. Negative 5, 0 over here on the left. 0, negative 6. And then back to 5, 0. So if I connect these dots, I'm not going to have a diamond. I'm actually going to end up with an ellipse, a vertical ellipse. So you should have a picture like that. So any questions with that before we move into the conversion part? We're just going to, with any of these, we're going to build a table and then make our sketch. All right, so now the conversion. So again, I can't just solve one of these for t and say, okay, t is equal to cosine inverse of x over 5. So now let me plug this into here. So y is equal to sine of cosine inverse of x over 5. That's a huge mess. That's not what we're going to do. What I want to do is think about it. Do I have anything that I've dealt with all semester where sine and cosine are related? And hopefully, even though I can't see your faces are lighting up saying, yes, I know, this is our holy grail. And the holy grail is what? Cosine squared plus sine squared is equal to 1. So do I have cosine squared? No, I don't. But can I get it? Yes, I can. By doing what? By squaring both sides here. So I get x squared, bring this squared into both pieces, 25 cosine squared t. But I don't want 25 cosine squared, I just want cosine squared by itself. So divide both sides by 25. So cosine squared is x squared over 25. So does that make sense there? I'm using my holy grail, and then I'm using the pieces that I was given to figure out what is cosine squared so that I can make that substitution. So all I have are x's and y's and numbers at the end. So do the same thing for the y. I need sine squared. So if I square both sides here, I have y squared is 36 sine squared of t. Divide both sides by 36. I get sine squared is y squared over 36. And don't forget this all equals 1. So this would be your rectangular coordinate equation. And remember now, what equation I get here has to give me the same picture as what I started with. And so if you kind of remember this problem when we get into chapter 11, ellipses, you'll see that this is the equation of an ellipse that goes 5 units left and right and 6 units up and down. And that's the picture that we have here. So that's how we know that this is right anyways. This is an equation of an ellipse. That's the picture that I had. So therefore, I know that this has to be the correct picture, the correct equation. Any questions on that one, number 2? As I said, number 6 is similar. Nobody asked about it, but if you do have a question later, that these problems are basically all the same problem. All they do is move the sine and cosine. Maybe they square one value and not the other. Maybe they square them both. But essentially, these problems are all the same. So the more of these that you practice, the better you get. So actually, speaking of that, let me talk to you guys real quick about the exams. So first of all, exam 2. I did talk to OIT on Tuesday. They told me how to go in, change the settings so that you guys could see the exam. So I did that. And then I asked my 126 classes yesterday and they still can't see them. So this afternoon, I'll call OIT again and find out what's going on. How is it that you guys are, what do we have to do so you guys can go back in and see that? So I did try to work on it. It's just unsuccessfully, apparently. So hopefully I can get that figured out today. If not today, tomorrow. All right. And then exam 3 and the final exam. So tomorrow I am meeting with the coordinator for 127 and the chair of the department. And we're going to talk about the final exam. Right now, I believe that the coordinator is leaning towards using Webassign for the final exam, which honestly, I think is probably a good idea because especially with these sections we're doing right now, I don't know if Canvas has quite the capability to handle some of these problems that need to be asked. Now, the good thing for you guys is you've been doing these assessments every Sunday all semester long. And essentially, the final exam would just be like another assessment. So you'd know exactly what you have to do. You'd only get one try at it, not 2. So you'd have to be careful with your answers. But I think that might work out better. So if that's the case, if he does determine that, all right, I'm going to use Webassign and I'm going to make the final exam through Webassign, then what I will do is your exam 3 will also be a Webassign exam so that you get used to what to expect. As I said, you guys kind of already know because of the assessments, but it would then be 2 parts. One part would be through Canvas, the concept questions, because obviously Webassign doesn't have the concept questions. And the second part would be the Webassign part, the problems. So after Friday, I will probably have a better idea on that. So I'll probably either post it as an announcement on Canvas, or I'll definitely make mention of it again Tuesday. But just kind of wanted to let you guys know where we're at on that, so that morning. Hey Sydney, no problem. All right. So any questions on that? Anything about the exams 2, 3, or the final? Okay, so let's move on to number 4. So obviously this is the last one we're doing today, the last one you guys had questions. So let's make this the attendance problem. So if you guys can put this in your ticket out the door notebook, this will count for attendance today. So the problem says x is equal to secant of t and y is tangent squared of t, but in this particular case, we're limited on what our values of t can be. And why is that? Well, if I use t is pi over 2 or t is 3 pi over 2, tangent of those values are undefined. And if I use pi, well, at pi over 2 and 3 pi over 2, secant is undefined as well. So that's why I'm restricted. I can't use all the values on the unit circle. So I'm just restricted to those values. So I'm still going to make a table with my t and x and y, but now I'm only going to choose 0, pi over 6, pi over 4, and pi over 3. And hopefully those 4 points give me an idea with what's happening with this graph. So does that make sense before I move on there? Why the last example, we used all the units from the unit circle, all the values. This one, we're restricted, so we can only choose these guys. Okay, I guess so. So x is secant of t. Secant, remember, is 1 over cosine. So if I figure out cosine of my values for t and just flip it, that will give me the values here. So cosine of 0 is 1. 1 over 1 is 1. Pi over 6. Cosine of pi over 6 is root 3 over 2. So flip that, becomes 2 over square root of 3, which if I rationalize it becomes 2 root 3 over 3. For pi over 4, cosine of pi over 4 is square root of 2 over 2. Flip it, becomes 2 over square root of 2, rationalized, just becomes square root of 2. And then pi over 3, cosine of pi over 3 is a half. Flip it, becomes 2 over 1, so just 2. Does everybody understand how we get, or I guess I should say, is there any questions on how we get our values for x? Okay, so for y is tangent, so this is basically just what's the value of tangent of t, and then square it. So for 0, tangent of 0 is 0. 0 squared is 0. For pi over 6, tangent of pi over 6 is square root of 3 over 3. So if I square that, it becomes what? 3 over 9, which is 1/3. Pi over 4, tangent of pi over 4 is 1. 1 squared is 1. And pi over 3, tangent of pi over 3 is square root of 3. Square that, just becomes 3. So if I draw this or sketch it, so my first point is at 1, 0. So that puts me right here on the x-axis. That's where this thing starts. And from here, where does it go? Well, pi over 6, remember I told you that square root of 3 is about 2. So if it's about 2, this is roughly 2 times 2 is 4. So this thing is about 4/3, 1 and 1/3. So if I go about 1 and 1/3 and then up 1/3, it gives me a point right there, almost right next to the first one. For pi over 4, square root of 2 is about 1.5. So this point here is 1.5 units over, 1 unit up. So it puts me there. And this point is 2, 3. 2 units over, 3 units up. So I got what here? I have a part of a parabola. Just the right half, not even the right half, just a piece of the right side of a parabola. It's a point here, no arrow on the bottom because it doesn't keep coming to the left. It starts here and just goes to the right forever, so it gets an arrow on the top there. So does that make sense there, that picture based off of our table of information? Any questions on that? If so, hit the exclamation point and I'll stop till you get your question typed in. Okay, so that's that. Now we need to convert it. So I will ask you guys this question. You can type in your answer here and make sure you're still with me. Like that involves secant and tangent. So what do I have that secant and tangent are tied together? Go ahead and type that answer in. Yep, perfect. You guys got it. So it's not our holy grail, but it's close. It is one of the Pythagorean identities, and specifically tangent squared plus 1 is equal to secant squared. Does everybody remember that? Way back when? So now I'm going to use the equations I started with and plug that information into this equation. Yeah, I knew what you're saying, John. It's okay. So do I have tangent t? Yes, I do. Tangent of t is just equal to y. So I'm just going to plug a y into my equation here. And plus 1 equals what? Well, do I have secant squared? No, I don't, but how can I get it? Well, I can get it by just squaring both sides again. So secant squared is just x squared. And technically, you could stop there. The equation is now converted. But if I move the 1 over, I get what? Y equals x squared minus 1. So remember what I told you from the last problem. The equation that we end up with has to give us the same picture. Well, if you guys remember from 126, y equals x squared minus 1, what is this? This is a parabola that slid down 1 unit. So this equation, if I just stop the problem here, this equation would give me what? It would give me this guy, the whole parabola. So that's why Webassign puts in what is x greater than or equal to and what is y greater than or equal to. So it is this equation, but only when what? X is greater than 1 or y is greater than 0. So this would be, if this was on the test, this would have to be the answer you give. If you just gave me that, y is equal to x squared minus 1, that gives me the whole parabola. And these parametric equations did not give me the whole parabola. It just gave me that part there. So that's why you have to put in these restrictions. Does that make sense to everybody? Any questions on that? Anything I need to go over any more on that one? No? All right, I guess you guys are going to get out of here early again. So, all right, so let me give you guys your ticket out the door. And so whether or not your exam and your exam 3 and your final exam, if they end up on Webassign, that's fine. It's still going to be these same types of problems. So these take it out the door problems are still good problems for review. So take it out the door, number one. If Z1 is root 3 plus I, and Z2 is -1 plus root 3I, find the following. So find A, Z1 in polar form, B, Z2 in polar form, and C, Z1 times Z2. Question number 2. So if X is equal to T squared and Y is equal to 1 minus T, then sketch and then convert to rectangular coordinate equation. And state the domain of the equation. So once you tell me what the equation is, tell me, so this basically means what? My x values. So what x values can I use so that I get the same equation back? So go ahead and try that. If you get stuck, that's fine. Go ahead and ask the question. If you finish, just go ahead and type done. After a couple of you have it done, then I'll put the answers up so you guys aren't just waiting around on me to give you the answers. Again, if you guys have any questions or once you're done, just go ahead and type that on. Okay. People another minute or two, then I'll put the answers up. Once I put the answers up, if you have them, great. You're free to go. If you don't, then keep working. It's not like I'm going to shut down the video on you just because other people have it. So I'll, again, I want you guys to make sure you know how to do these. Make sure you get these answers. The answer is important. It's more so, do you know how to get the answer? That way, if one of these shows up on the test, or I guess when this shows up on the test, then you'll know what you're doing. So I'll give you guys the answers. Again, if you have them, it's good. So for the first one, Z1 in polar form. And so Z1 is 2 cosine of pi over 6 plus I sine of pi over 6. Part B, Z2 is 2 cosine of 2 pi over 3 plus I sine of 2 pi over 3. In part C, the product is 4 times cosine of 5 pi over 6 plus I sine of 5 pi over 6. Any questions on that one? If you do, you can ask it and I'll come back to it. For this guy here, number 2, the graph is going to be a parabola that points to the right. You have two possibilities for the equation, depending which way you substitute it. You can have either y equals 1 minus square root of x, or x is equal to 1 minus y squared. But again, we need the domain for these guys. So we need what? We have that x has to be greater than or equal to 0. So it's either of these equations is fine, but with the restriction, x has to be greater than or equal to 0, which obviously for this one makes sense because you can't have negative values for a radical. But over here, well, it's still going to be greater than 0 anyways because it gets squared. So this one, not such a big deal because no matter what you pick for y, it's going to equal, x is going to be bigger than 0. But for here, we're worried about the restriction. X has to be greater than or equal to 0. And that gives us that picture there, the parabola pointing to the right. So any questions on either of those? As I said, if you have these, that's great. I will wish you guys a good weekend and safe few days here. We'll see you on Tuesday. If you didn't get it, or you thought you had it, but the answer was wrong and you're going back to work it, that's fine. I'm not shutting down the video stream until pretty much everybody has done what they need to do. So if you guys are going to leave, have a good weekend. If you stick around, that's fine. Just let me know when you're done or when you're leaving, or if I see the number of viewers start dropping down, I'll assume that you guys are done and heading out. So yeah, keep working this. If you didn't have it finished, go ahead and keep trying to work it. Try to get the answer until you get it. All right, Paula, have a good weekend. And again, don't forget, you guys, on 9-1, make sure you use that drop-down menu for your I's and J's. Don't use the keyboard. Okay, Faith, have a good weekend. Will, have a good weekend. Okay, Leilani, have a good weekend. Okay. Yeah, if not, if you guys still have questions, if you do get offline and then you still have issues, shoot me an email or something and I'll try to, get back to you before either the homework deadline or. Yep, go ahead, Jay. Sketch for the second one when you use the equation. So if x is 0, yeah, so what's going on there? Did I sketch this wrong? Maybe I sketched it wrong. Oh, it is. Yeah. Sorry. Yeah, so it is shifted up 1. I drew the picture wrong for you guys there. So yeah. Yeah, you're right. Yeah, I just drew it wrong. So yeah, the vertex is at 0, 1. Yep, sorry about that. Thank you, Jay. Yeah, I started wondering too, like, what did I do? Yeah, so it helps if I like look at my picture and draw it like what I have. So yeah, thanks for pointing that out. So hopefully everybody else had it right and just didn't catch that. So good catch on that. Okay, Sydney, go ahead. On that note, done. All right, Jay, you too. Have a good weekend. We'll see you or talk to you, or I'll talk at you, I guess, on Tuesday. So have a good weekend. Be safe. Okay, was the sine and cosine one? Oh, because you got here late, right after we started it? No. Oh, on the TOD. Okay. Okay. So we have two options. We want to solve one of these to be t equals something and then plug it into the other one. So that probably the easiest way is this guy here. If I just take square root of both sides here, I have square root of x is equal to t. So then if I plug this into here, actually this should be plus or minus. So y is, yeah, this should be plus or minus actually. Yeah. So plus or minus, so we plug that into there. So you get y is equal to 1 plus or minus square root of x. That's what gives us this piece here. Or the other way is this guy here. If I solve that one for t, if I bring the t to the left and the y to the right, I get t is equal to 1 minus y, and then plug this into here. So that's probably the less confusing one because we're not dealing with the square root. And so then once you plug it into either one, you get x is 1 minus y squared, or y is equal to 1 plus or minus square root of x. So either of these equations would be okay. Does that make sense? Yeah, because if we only have 1 minus square root of x, it's only going to give us this part down here. But we also want to include the top part of the parabola, so that's why we got to have the plus as well. Okay. Yep, sorry about that. So I got to fix that on my notes. All right, any other questions or anybody still working this? You need me to hang around for a few minutes? Otherwise, I will shut down the video and see you guys. All right, thank you. Okay, you too, Sydney. Have a good weekend. Who's here? Somebody. Hey, Bambi, come on. You want to say hi to everybody? Come on. For all you still around, Bambi wanted to see what's up. Say hi to everybody. All right, out you go. Okay, so I will say bye to everybody. And if you do have any other questions, then yep, what good thing you stuck around. Got to see Bambi. You're wide awake today. How come? How come you're so awake? You want a treat or something? Okay, come on, let's go get a treat. All right, we'll see you guys on Tuesday. Have a good weekend.